everyone, I welcome you all to this 30 days masterclass series on electric vehicle design using MATLAB Simulink. Today is day 30, electric vehicle model prototype design. I welcome all the participants. I welcome Robert, Mohammed, Shiva Periyasamy, Ramachandran, Sai Vinod, Dr. C. Saravanan, Srinu, Ramesh. Very good evening participants. Ganpati, is Lord and Umesh, Arpreet, Ajit, Arun Kumar, very good evening. So we almost reached the day 30. So we successfully finished the 30 days masterclass series. Yes, very good evening, Shiva Kumar, Advait, very good evening. Yes, it's a last day. Very good evening, Vedant. Very good evening, Jamil. Yes, I welcome you, everyone. Am I audible? Can you please confirm? Am I audible? Am I audible? Can you please confirm? Yes. Good evening, Shivam. Good evening, Dr. S. Vijayalakshmi. Good evening, Sachin. Good evening, Dabastri. Very good evening, Kushbu, Benobin, Jida. Thank you, participants. Thank you for your reply. Yes. So about Pantech is a educational equipments manufacturing company. From Pantech, you can get lab equipments for EEE, ECE, computer science, IT related products. You can get it. And our vision is to help 10 million students to learn the technology in easy way. So far, we have trained about 10 lakh students. So this is, so today I will share you one by one. So what is a block diagram? What is the schematics? How to start your program? Everything I will give you one by one. So please try to engage with the entire class. Right? Right. So here this is our EV prototype. So it's a basic model we have selected, and in this one, so this is called a rear wheel left wheel drive, right? So this is the rear wheel left drive, and similarly this is a right wheel drive. This is the right wheel drive, and next one, this is the free. The front wheels, two wheels are the free wheels. So again here, so we just used only for the direction control. And after that, this is the steering system. So we used the old, universal drive. So universal giant. Here we have used the universal giant to move lefts or right, something like that. And here we kept two control unit. One is called acceleration, and another one is called deceleration. So the acceleration or deceleration, nothing but in the microcontroller we developed application code. In the code, if the particular port is keep on high, then the acceleration may work. If again for the deceleration, again we took another, we assigned another port, and if that particular port is keep on high, then we will apply a deceleration, right? So we will reduce the duty cycle. So immediately the duty cycle, duty cycle has reduced, and then braking mechanism has been applied to stop the vehicle. So this is very basic, functional informations. And after that, here we kept the battery model, and so here the power control unit, nothing but here we used two PMDC as per our yesterday calculations. We used two numbers of PMDC for rear wheel, left side as well as the right wheel drive. And so for each and every motor, we used one separate chopper, so that if you keep chopper, then you can drive your vehicle in the forward as well as the reverse. Right? So this is the detailed functional block diagram of the EV prototype. And so in the block diagram, so here from the battery you will take you will get a power, and that power is connected to the 4-quadrant chopper. So here we kept two 4-quadrant chopper. So here we kept two 4-quadrant chopper, and after that left wheel motor, similarly right wheel motor. Not the front, this is the rear, right. Yes, the rear right wheel motor. And after that, driver input has been connected. So here the two inputs given. So the driver will apply a acceleration as well as the deceleration. So from this one we will take a signal, and then that signal is connected to the microcontroller. So from the microcontroller we will connect the same signal to the chopper via the driver. Right. So this is the functional block diagram. So do you have any questions about the block diagram? So this block diagram only for this EV prototype. So this block diagram is only for this EV prototype. So do you have any questions about the block diagram? If you have any questions, you please comment here. If you have any questions, you please comment here. Attendance details will be shared by email in another 1 or 2 days. When will give certificate? So please check the starting of the class. Get detail. So do you have any questions? I am just waiting for your reply. I am just waiting for your reply. Just please comment. So please ask your questions. I will try to give you the answers. No, thank you. MCU nothing but it's a microcontroller. MCU nothing but it's a microcontroller. Any more doubt? Have any questions? You please ask me. Thank you. Thank you, participants. Thanks for your comment. Just a second, I will share. Yes. Just give me 2 seconds. I will take a file. Yes. Certificate will be provided probably 11th. 11th. Yes, for direct internship, you will get a hands-on training. Attendance list I will share you in another 2 to 3 days. In another 2 to 3 days, I will share you the attendance form. Just a second, I will take a. Just a second, I will take it. So here in this microcontroller we used TS-PIC 30F4011 microcontroller we have used. So TS-PIC 30F4011 we have used. Placement, yes, you may get a placement in the direct internship. In the direct internship, you can get a placement. Yes, no, there is no any motor in the front wheel. So there is no any motor in the front wheel. I will show you the vehicle, and the assumption that actually in this I have two type of demo. One is that lab test demo, and another one is that with load demo. Right. So in the lab test, we have not included the battery. So in the lab test we used the grid power supply to accelerate and then decelerate the vehicle. Similarly, I have one more demo like with load. So in the load, complete grid power supply has been removed, and then I will show you. And in the yesterday class also I have I show you the demo of that. On road test demo, right? So I will give you the I will share you the information just a second. And there is no any motor, and then two PMSM controlled simultaneously, then can't use single chopper. No, we have used two chopper, not a single PMSM, it's a PMDC motor. And yes, for direct internship, please contact our people, will give you the informations. 98409-74407. You can contact our director so to get the complete information about the direct internship. And then certificate I will release on March 11th, Mr. Gowda. I will release the certificate on March 11th. Yes. So now in the lab test we kept this. This is the typical rating. So 24 volt DC power supply we have used. 4 quadrant chopper. The chopper 1 will generate 0 to 24 voltage, and similarly for the chopper 2 0 to 24 voltage. And then both the motor will run at maximum 100 RPM. So both the motor will run at maximum 100 RPM. Then that is the maximum. So for this voltage range, you may get like that. And after that, we implemented in the chopper. So this is the chopper control as per our theoretical concepts. If you turn on the switch 1 and the switch 4, you may get a forward. Similarly, for switch 2 and switch 3, you will get a reverse bias. So this is the gate driver circuit which we have implemented, and by part we have implemented this model, right? So by part we have implemented this model. And see here for the this is the one set of the chopper. Similarly, we have used two model. Similarly, we have used the two model, and after that, the vehicle specifications, PMDC motor operations is going to be a 4 quadrant chopper, and speed will be like 100 RPM, and vehicle speed is maximum 20 RPM. So that is a 20 km per hour. And brake, we have used the regenerative brake. And controller, actually there are two type of motor controller. One is called the DSP microcontroller and Arduino microcontroller. So these two microcontroller we have used, but we used DSP 30F4011 microcontroller. I will show you the demo. So before into that, this is the flow chart. So first we have to initialize the flow, all the pins, then just assign the pin diagrams as per the 3-phase induction motor, and verify the mode, like whether is it in the forward mode or reverse mode. And after that, main functions will be there. So it will check acceleration or decelerations. And so generate a duty cycle. So here the duty cycle is simple, like whatever we developed the logic. So the PWM logic. And this is the prototype, EV prototype. So this is a version 1 prototype. So now it is something different. Why battery standards are 48 and 72 for EV? See, actually 48 is the earlier version. Nowadays comes up with the 72 voltage, because if you are increasing the higher power rating, so this 72 is the typical voltage range for the terminal motor. So that's why people are keeping the 72 voltage. But many luxury EV vehicles comes up with the 360 voltage. Luxury vehicles comes up with the 360 voltage. What is the price of Arduino controller? You just check it in the Amazon. You may get a latest and then updated price. You can check it. Yes, Dr. Deepika Chauhan, please take my number 98409-74408. You can ask me any questions related to your requirements. And I will show you the demo. See here, actually initially we run this equipment for the lab kit, lab test. Here, just a second. Yes. See here, we take the power from the grid, and via the grid, actually this is the 24 volt power supply generator, and after that we applied this same voltage to the motor. See here, the motor is connected and the microcontroller, and see we used the motor controller as acceleration for the and deceleration with the help of that sealing machine motor control. So because actually we try to implement whatever the materials available with us, so that's the logic we actually we use. And after that, so this is a detailed image, and so the lab test waveform verifications and all everything. And similarly, you have a more demo. So in the internship portal, you may get a detailed demonstration. So here we have to verify the input to current, how much current is going to take, and then what is the terminal voltage. So before get into that topic, you have to ensure all the measurements so that you can run the vehicle without any issues. But actually, in the market, you I mean you may get the complete model. See, for example, I will tell you this one. Just to go to the Google and take a DC motor control, 24 volt DC motor controller. So you may get this kind of blocks. You may get this kind of boxes. So here, whatever you yes, see here. So there will be a, you can use this box also, but you cannot program the, you cannot change the program and all. Simply if you change the potentiometer, then you may get a speed control. But in this logic, see here there are that four wires are there, and then additional two wires are there. So one is that two battery battery plus and minus, and another one is that motor. So like this you can keep, and after that you have to connect potentiometer. So now if you change the potentiometer, see here, this is the potentiometer. If you increase the potentiometer, the speed will get increased. To decrease the potentiometer, the speed will get decreased. So like that, this charge will work. This controller will work. But for dedicated application, this is perfectly okay. But for the EV prototype, so you must develop this kind of controllers. So first you have to implement the microcontroller, and after that some additional parts will be there. So I will tell you one by one. Yes. And so these are all the mechanisms which we have used. Yes. See here, if you take this image, yes, can you able to see this block components in detail? Can you comment? Can you able to see this detailed image? Can you please comment? See here, this is the PWM controller and chopper model and then driver model. So each and every driver model will be powered up individual transformers, because the isolations must be introduced. The isolations must be introduced, right? Thank you, Mr. Arjit. Yes. So now, yes, I will. The pin diagram and then detailed circuit diagram will be available on the internship portal. If you are interested, you can go and then download all the circuits and then code, microcontroller codes. Everything you can get it from the portal. And after that, just a second. So here now you have to, yes, detailed close up image. And yes, so here we will use the, yes, now we are going to turn on the PWM. You can check in detail. Switch, yes. See here the duty cycle only, the RPM is not properly configured. So now the mode is in the forward mode. So now if you apply that acceleration part, then here what is acceleration? Nothing but you just increase the duty cycle. So when you increase the duty cycle, then the voltage across the terminal of the motor is going to be increased. So now we are just increasing the increasing the duty cycle. Then here, so the duty cycle has been increased. Similarly, if you decrease that, if you apply a brake, then the duty cycle will approach to 0. So like that, and then see here the initial current of the load. So here initially the load has not applied, so that's why it shows that 29 voltage, but the motor will draw 24 voltage only, and 1 ampere is initial 1 ampere because the motor is already powered up with the gear. So now this, so if you apply the motor, you increase the duty cycle, then the motor will get increased. Motor speed you may get this. Now the current is slowly it's get increased. Yes, keep on increasing because the motor try to rotate from its standstill position. So due to the initial gear, then it's sourced like that. Now you may get a, yes. See here the vehicle is started to run. The vehicle is started to run. So similarly, you can get so if you reduce the speed, then the motor will approach to 0. Right. So now and after that braking mechanism, see here now we are enabling the regenerative braking. So if you apply the regenerative braking, then the motor will immediately get stopped. You apply the regenerative brake, then the brake will get applied immediately. So the motor, yes, see here the motor brake has been verified. So the same thing we have tested in our laboratory. Just a second, I will show you the videos. So same thing, the same hardware we have used, and here we have added some of additional informations like some of additional information like a dashboard. In the dashboard, that LCD model and the brake mechanism, forward, reverse, everything we have included. Complete load test. So you can get this video from the internship portal step by step, right? You can check one by one. And so this is the, somehow we have increased the additional load. So forward as well as the reverse. I will share you this video in the internship portal, detailed demo video, and soonly we will give you the detailed unboxing video of this EV prototype in our YouTube channel. So you please check. So yesterday only that demo has been finished. Yes, forward as well as the reverse model. Make it detailed up. I hope you got some idea about the TV prototyping. So with your available locally available material, so no need to procure or no need to purchase anything. So all the motors and then all the components will be available locally. You just try to use that components. So you no need to import anywhere from the market. So all the components will be available locally in the local market itself. Right. So this is simple, similar hardware information. So you can use it for your research applications. So cost approximately we spent about 50 to 60,000 rupees. Just a second, I will share the attendance form. Attendance link, just a second, I will share you. So in our branches like Hyderabad and then Chennai, so you may get a physical internship. So you can, we will assist you how to develop this similar kind of EV prototype in our laboratory. So like that support you may get it from our Pantech. Thank you, Mr. Madhav. So due to the vehicle, sorry, video play, then when it's happened, in hang. So if you feel that you scored something about the EV, so please share your video feedback to my WhatsApp number. I am eagerly waiting to see your feedback. Please check your, please submit your attendance form, and I hope you have enjoyed the class for next 30 days. I am going to miss you everyone since I completely tied up with you everyone for past 30 days. Definitely I am also going. I will share you by March 7th. Thank you, Sai Prasad. Thank you, Sai Prasad. Thank you. Yes, Bansat. Dubai, thank you so much. Thank you, Gauda. Thank you so much. Pavitra, thank you, Sirimuntha, thank you so much. Keshav, I will share you the certificate in another 2 to 3 days. Thank you, Blood. Thank you, Balekar. Thank you, Chetan. Thank you so much, Mr. Vasant Kumar. Thank you, Abhi Armugam. Chennai address, you please WhatsApp me. I will give you Mr. Suleiman. So take my WhatsApp number. Those who are all needs a direct internship, you can come and meet our people. Thank you, Muthu Subramanian. Thank you, Dr. S. Vijayalakshmi Madam. Thank you, Venkatesh Reddy. Thank you, Aruna. Thank you, Aditya. Thank you so much, Ajay Meena. Yes, thank you so much. And dear Gauda, please connect me in WhatsApp. Thank you, Venkatesh. So video access only, not a video download. So please check. Thank you, Dr. K. Kalachelvan. Thank you so much. I am requesting you everyone. So please share your video feedback to my WhatsApp number. Please share your video feedback to my WhatsApp number. Thank you, Santya. Thank you, Vishnu. Thank you, Srikanth, Asif, Jay Kumar, Nitesh. Thank you so much. I am going to miss you everyone. Thank you, participants. Thanks for your valuable time. And I wish you everyone become a EV engineer. Thank you, Srinivasan. Thank you, Mohammed, Bridget. This attendance link I will ping you. This attendance link I shared already. Here I will share you once again. It's in the top of the chat, so please check. And those, if you want to join in the internship, you please find the link in the description, this video description. So please check once again. Partners link again. I am going to ping in the WhatsApp, sorry, in the chat. Video. Thank you, participants. Thanks for your valuable time. And if you have any doubt related to the electric vehicle, related to the renewable energy, and then MATLAB Simulink, I'm here to help you. I'm here to help you. Pantech always will help you, everyone, to learn the skill set. Thank you, participants. Thanks for your valuable time. Thank you so much. We will meet you in the next 30-day masterclass. Hopefully, we are going to launch EV charging stations. We will send you the invitations link by email as well as the WhatsApp group. So keep engaged with our entire social media. Thank you once again.